I still have some juice left on this battery, so I wanted to talk about something that I've seen a number of people mention in YouTube comments on my video on this anvil. This is the Harbor Freight 55-pound cast iron anvil, rugged cast iron anvil. And several people have commented, and when I say several I mean at least 3 or 4 have mentioned anvil to hammer weight ratios. That it needs to be at least 35 to 1 or 40 to 1. Oh, you should have a 50 to 1 hammer to anvil ratio. 50 to 1 anvil to hammer ratio. Apologies. Why are they saying that? Well, they're saying that because that's a common rule of thumb that they've heard. Rule of thumb. Common. Yeah. That rule of thumb is an old rule of thumb. It doesn't really apply anymore. Not to modern anvils, but to modern stands, modern attachment methods, modern concrete slabs with anchors. This anvil is 55 pounds, and if we go by a 40 to 1 ratio, that means the heaviest hammer I should ever use with this anvil is a 1.1, 1.2 pound hammer. I really shouldn't be using a very heavy hammer because it's going to damage the anvil, right? No. If this is soft enough to dent with a hammer, it doesn't matter how thick this is. It doesn't matter how heavy it is, it will dent. Period. If this thing were a 500-pound rod of cast iron, the end of it would still dent just the same as this anvil because of the softness of the anvil. Now, what does affect the durability of the face? Hardness. Hardness determines whether or not the face of the anvil will dent. So what does the weight of the anvil determine? The weight of the anvil determines how much work the anvil will do, or rather, how much the anvil will move while it is being used. See, if this is a loose anvil, see that? Tap, tap. Can you see it rocking? That's what hammer to anvil weight means. If I use a small hammer, anvil won't move as much. If I use a heavy hammer, the anvil moves more. That's what hammer to anvil ratio means. If I were to be using a sledgehammer, really I should have an extremely heavy anvil to be working on. But that's not realistic, and most people who use a striking anvil with 6, 8, 15, 20 pound sledgehammers, it's a 2 or 3 inch thick block of steel, maybe as much as 5 inches wide, 14 to 16 inches long at most. That is maybe a 70 or 80 pound piece of steel at most, and it has a stand, which is typically welded to the block, and then the stand is anchored to a concrete slab. The striking anvil does not move even when being struck with a 20-pound sledge. Well, if I were using a 20-pound sledge, I guess I should be having a, 2,000-pound anvil? Something extremely heavy. I know that math isn't exactly right, but you get the point. Back when we didn't have proper retention methods for attaching an anvil to a stand, we didn't have nuts and bolts, we didn't have metallic stands that it was easy enough to either weld the anvil to it or drill holes through the stand and then bolt it down. We had to use nails, and we had to use lag bolts into a stump, and in those cases the anvil could jump around more, it could rock, and we needed a heavier anvil for the weight of hammer we were using, so that we didn't have to resituate the anvil all the time, and we wouldn't lose energy to the anvil moving around. But no, the weight of the anvil will not affect my testing, because my testing was not about how much work the anvil does. My testing was specifically about whether or not this face is durable enough to stand up to normal and light use. Not heavy use, light use. It did not. I found in my testing that it was far too easy to deform even with hot steel. Should remember something else. When I'm hitting hot steel, that steel is not hard. It is soft. It is incredibly soft. It is incredibly malleable. It behaves more like a liquid than a solid when it's being struck. It deforms. It's plastic. The closest representation we have at room temperature, and the one we use to demonstrate certain techniques and moving material, is clay. If we forge clay on this anvil, yeah, that's a pretty good demonstration of what it's like to forge iron. It just moves more quickly. I hope the wind isn't getting up too much. You can't hear me as well. But I hope you get my point that the hardness of the anvil does not affect work because the workpiece absorbs the energy and does not transfer energy into the anvil. And if it does, the anvil literally cannot transfer energy back into the workpiece like it can with a hard hammer. This hammer can bounce, even though this material is soft. If this were a hot workpiece, however, and I dropped this from 3 feet, it wouldn't bounce at all. And I can't demonstrate that with a hard anvil and, well, relatively hard anvil and a hard hammer because they will always bounce. But on a workpiece, it will not bounce. Drop a ball bearing onto a hot piece of steel. It goes like that. It doesn't bounce. It doesn't deflect. It just stops. Hardness of the anvil face does not affect work. The weight of the anvil does not affect face durability. They are mutually exclusive. Hardness affects durability. Anvil weight affects sturdiness and work. That's all.